there's an element of hubris which has perhaps crept into our profession. We kind of believe that we know many things. We can tell other people many things. And, Ariel is a very severe critic of these attitudes. But it's always extremely refreshing and thought-provoking to hear Ariel. I heard him maybe a couple of months ago at a conference in Chicago on a panel discussing the future of economic theory. I mean, Ariel's views I thought were the most interesting, but they were also the most unsettling and uncomfortable for many people. But I think it's a view that I personally have a lot of sympathy for. There are many things that we need to think deeply about, but to be less sure about our conclusions or the sorts of things that we arrive at. In any case, Ariel is much more than a brilliant theorist. I mean, he's a deeply engaged political person and has many interests, coffee houses among them. So I encourage you to look at his website, read his papers, but also look at his website for many interesting things. So it's a great pleasure to have him with us today. Ariel.
Well, thank you very much. It's a little strange because I don't see, I was looking for a screen and there is no screen. Okay. So, most of my work in my life, I've done theory, economic theory, game theory, and so on. But in the last 12 or 15 years, I was doing also some experiments. I don't plan to continue doing it, but for a variety of reasons that probably you will understand later. But I want to tell you a little bit about some research that I've done, especially in the last 10 years, and summarized in this paper, which in many respects it...
There's a double microphone. If you take that all the way, that's what...
Thanks. Good. So... that in many respects summarize my views about experimental economics. There are two goals to this paper. The first goal is connected with the notion of typology. Any model in economics, any model in economic theory, in any model, we have some typology of economic agents. For example, we talk about, we differentiate economic agents by the risk aversion. So risk aversion is a type of typology of individuals that is very common in economics. In the last few years, from theoretical point of view, what I try to do is to try to build models with different typologies. This brought me to think also from experimental point of view to try to demonstrate that there are some traces of those typologies in data, and the particular typologies that I have in mind here is basically more or less the following. We very often differentiate people along the line or let's say we say about a person, he's an instinctive guy. What do we mean by this instinctive guy? We mean that we don't actually know how does he make a decision, but we observe his behavior and we know him And we have seen many times in the past that he made decisions that we associate in our mind or we classify as instinctive. On the other hand, sometimes we say about somebody is very thoughtful, what I will call a very contemplative. What I will mean by that is I know him. I don't know how he does make decisions, but I have the feeling from the content of his decision that he's thoughtful, he's contemplative. I would like to make this distinction, or I would like to suggest the typology of decision makers, economic agents, along the line between being very instinctive and being very contemplative. So that's the main goal of the presentation. There is a second goal, and the second goal, which is covered partially by my picture, is to demonstrate, I should say once again, the importance, or the usefulness of response time in experimental economics. I'm quite, first of all, I'm not the first to think that response time is important to understand or to give interpretation for behavior. Here is a picture of a name from the 19th century of psychologists that has done it. There is a difference between the ways that psychologists talk about response time, where usually they talk about units of milliseconds, and we talk about something a bit different. But of course, there were many psychologists who were understanding or were thinking about the importance of response time in interpretation or in understanding behavior of human beings. I am obsessed in the last 15 years with this issue, partially as a sort of a response to neuroeconomics, because I believe that response time is a very easy, very cheap way to that plays a similar role to what fMRI does in interpreting choices. And I think that this approach was, at the beginning, was received with skepticism among experimental economists, and I had many difficulties to publish the first papers on the subject. Now, actually, the mood completely moved to the opposite, namely, it's difficult to publish papers without response time. Both extremes are bad. But that's the second, in any case, that's the second goal of my presentation. Let me say, we are going to talk about to use response time. Response time, what does it mean? It means the time between the moment that the computer sends you get the problem on your screen and the time that you click the response. Response time is a very noisy variable. And in order to say something about response time, in my opinion, you need a huge set of subjects. And the ways that I gather the information or I get the data in this study is through the website that you see here on the left. That's a website that I built about 15 years ago. And let me tell you a little bit about, for 30, 60 seconds, is the story of this website. For many years, I was teaching game theory. And when I was teaching game theory, I was quite careful to warn the students that should not take the game theory too seriously. Namely, that you should not take the prediction of game theory as sort of prediction of the world and so on. And the game theory is very interesting, etc., etc. But, and the best rhetorical way that I found in order to demonstrate it is by the following: is to give students before class to some problems, some games to play, not really to play, but to think what would they do if they would play the game. And then once I come to class, to say, oh, here is the game, the prediction of game theory or the Nash equilibrium or whatever is such and such. These are the results of yourself, not of students from Alaska, but these are the results of yourself. And once there is a big difference between the prediction and what the students themselves did, I think that this was a very effective way to demonstrate this tension between the meaning of game theory and reality. Now, the story of the structure of this game this website is the following: there is a bank of problems there, games and choice problems, something like 150 problems. You as a teacher can register to the site. Then you can assign to your students whatever problems you want. My instruction to teachers is before, give the problems before, don't give them as exercises, but give them before you teach a particular topic, give some problems to the students, and then discuss, again, the conflict between their results and the game theoretical solutions in class. It's not the most popular website in the world. I mean, there are several more, but I think that overall it was not unsuccessful. And I have something, we have something like 50,000 students were participating in the past in this experiment. They are from something like, I don't see the numbers, but I think 300 classes from about 50 countries. That's not a representative sample of the world in any way. It's even not a representative sample of students of game theory, but nevertheless, it's much more representative than the samples usually used in experimental economics, where more or less it is the sample of students in GSB Stanford or Northwestern or the Hebrew University. It also includes some students from very small countries like India, China, that usually are excluded from those experiments. Because of some reasons, actually, the countries in the red actually are more representative in this sample than others. Okay, now some preliminary. When I will talk about a problem, I will mean a problem. Some either choice problem, or usually here I will talk about a game. It's, again, the game you will not play interactively. It is just imagine that you play the prisoner's dilemma. What would you do? Things like that. Response time, to be more technical, is the time between the moment that the computer in Tel Aviv sends you the problem and the moment that it gets the result. Given the speed of communication these days, that's basically the time that the problem is on your screen. I will use a lot the concept of median response time, referring to variety of populations. You know what it is. I would like to talk for a second about a concept that you will see again and again. This will be my rhetorical trick to show you again and again many pictures, and the picture will be very similar. And the pictures usually will demonstrate what I will call cumulative response time distributions. Let me show you let me demonstrate it by the following problem, which is not belonging to the lecture, but it is just for introduction. The following sentence, count allowed, not allowed, please not, the number of F's in the sentence, count them only once, don't go back and count them again, don't cheat. Of course, people cheat, but who cares? And here is the text. You might look at it for a second, count the F's, and now complete the following statement. Number of F's is the sentence is such and such. Okay. Now, here the story is that some of you, I'm sure, found the number 3. Some of you counted 6. I guess nobody counted 7 or 2. Whenever I count it, I always get to 3. I remember that it's wrong, so I count it again, and then etc., etc. And of course, I'm a person that reads only one word in 3. So of course, I am a very typical person to skip on these three offs. And many of you did as well. Some of you skipped only on this off and counted 5. Some of you skipped on these 2 offs and counted 4. There is about 2% of you guys or something like that counted 7 because you counted 1, 2, 3, 5, 6, 7. That's the most. That's what we have here. Okay, so in some sense, okay, now this is just fun. And now to demonstrate to the point, so what you see here is this cumulative response distribution. What do I mean by that? I mean by that is you see here, each of the lines here represent a population that answered a particular response. So here is the population that answered 3. They are the quickest guys. Namely, this is the distribution of their response time. This means that 50% of them answered within 42 seconds or something like that. Okay, that's clear? So that's the meaning of this graph. Such and such proportion of people answered within such and such time. What you see here is something which is extremely typical. It is regular, something which I would call it regularity in this. I have hundreds of problems and almost thousands of pictures like that. It always look like that. What do you mean by always look like that? I mean two things. Number one, the shape of this response, this cumulative response. It is always look something like that, and let me highlight the points. First of all, there is about 5% of the people. At the beginning, there is one big mass. Why? Because there is about between 5 and 10% of the students, they just click. Just click. So they click quite randomly, and there is not much meaning to what they do. Then what I have is always a shape like that. I try with a statistician to fit to it some distribution. It's close to log normal, but it's not exactly log normal. But it's definitely not log normal, but it's something in this direction. That's something which is always the case, of course, when the population is large. The largest population, you get a graph which is smoother. It's so smooth that you want to take derivative. I don't. Second thing that is almost always regularity is that there is a clear, what we call in economics, first order stochastic domination of the graphs. You don't expect that everybody who answered 6 thought more than everybody who answered 3. This would be complete nonsense. But you would expect that people who answered 6 were more careful, more thoughtful, more something, and therefore thought more about the problem. And so the distribution of time, response time, is first order stochastic dominates those of 3. And that's exactly what you see here. This is the 6, this is for 4 and 5, and this is for 3. You get a very clear confirmation here of the intuition that people who are more careful answered more correctly for this problem. Okay, that's again just to demonstrate the tool. Now, there will be several stages to my study. So again, the target is to suggest a new typology. First of all, when we talk about, let's say, risk aversion, what does it mean in life that I'm a risk-averse guy? It means that we agree about what is a risky action, what is a safe action. I'm a risk-averse guy. It means that most of the cases, or more cases than I am taking the safe option. So there is, first of all, there is some agreement about what is safe and what is risky. I'm going to talk about more instinctive and more contemplative. And first of all, I would like to achieve some sort of agreement about what, or to identification of what is instinctive and what is contemplative. In the previous problem, I think that it's quite clear that if I would have to say what is instinctive action, I would say probably 3. The more careful, contemplative, thoughtful is 6. But in any case, so how do I do that? I take 10 games from the website. Now, how did I choose the 10 games? I choose them because of the following reason. First of all, I have to explain it because I have many more than 10 games, and I chose particular 10 games. I chose them because, number one, I have a lot of many subjects. By many subjects, I mean thousands. Number two, in my opinion, and this is a very subjective statement, of course, in those cases, indeed, there is a clear distinction between contemplative and instinctive action. Number three, the distributions of response time for the various actions were significantly different in those cases. And that's basically the reasons. And what did I did there? What I did is that I will demonstrate it now. I will not have time to go through the 10 games. But in each of the games, I identify the actions which are the responses, the typical response time is below the median response time and above the median response time. So again, I'm taking the actions. Let's say there are 4 actions in a game. I will identify what is above the median response time, what is below. But let me say right away, especially since we don't have much time, that I'm going actually to identify those which are above median response time. I'm going to call them contemplative. Those which are below, I'm going to call instinctive. Why I'm going to do it? Because actually the truth is that, first of all, because my very subjective judgment is, or intuition, is that these are the more instinctive and these are the more contemplative. Nevertheless, many people don't like the subjective approach that I take here, and therefore ignore it for a second, for 10 minutes. And at the moment, if you don't like this subjective distinction, just think about it. I'm going to take games. In each of the games, I will identify what are above the median, what are the actions which are below the median. And again, I took games where there were the classification of what is above and what is below is relatively quite clear. Demonstration. Here is a game. Here is a game, two-player game, and you are player one in this zero-sum game. You are player one in the following game. Imagine that player two is anonymous. What will you play? Look at this game for a second. Think, what would you do? Let me tell you what the subject did here. The pool here is something like almost 5,000 students, not so little. And see, these numbers are not very interesting for me today. This was for games, for other issues. But so I will report them, but please don't take them, don't think about them so much. So the majority, 62% choose the top, the rest choose the bottom. Here, there's just two actions. Look at, first of all, the median response time. There is a huge difference here, 41 versus 57 seconds. That's huge because it's not just 16 out of 58, it's 57 minus x versus 41 minus x. Namely, there is some x time that it takes to look at the problem. So this means a huge difference between those who answered B and those who answered T. What you see on the right is my rhetorical graphical trick, which you will see again and again. It's not just the median is above, but the entire distribution in red is to the right. It's very clearly first order stochastic dominates the distribution of the top. Hereby, I'm going to declare that the fast action here is T, the top, the slow action is B. But again, since the time is short, let me say, I hope that you are identified with my feeling that the action which is instinctive here indeed is to take the action T. Why? Because the T, if you don't think too much, if you actually don't think really strategically, you have here either 2 or 0 or 0 or 1. So the action T is associated with the higher payoff. So the instinct is to take T. More thoughtful thought would be to say, okay, I will choose B because I will think about the other player, and it's very clear that the other player actually will play R, and therefore, because he is probably instinctive, and the instinctive there is to go on the lowest payoff, lowest loss of 1 versus loss of 2, and therefore I will choose B. But the first thing that comes to mind is probably to choose T. In any case, slow T, slow B, top T. Okay? Game 1. Game 2. This is a version of a telling Main Street game. The story here, imagine that you are a manager, well, of course, chain of cafes, that's my obsession with cafes. But in any case, let me summarize what is written here. It's a telling, but this time it's a telling on a street which is discrete. There are 7 positions. The population is uniformly distributed in the 7 positions. You have to select one of the 7 points. It's a version of a telling where there are 3 players and not 2. If there were 2 players, of course, the Nash equilibrium and also the instinctive action is to choose the middle. But here there are 3 players, and just for curiosity, there is actually, it's a very good exercise for students. There is a unique mixed strategy Nash equilibrium here, which is on the bottom. Namely, it's 0, 0, 40, 20, 40, 0, 0. It's concentrated in the center, but actually not really in the center. It's a little bit on 3 and locations 3 and 5 gets actually the big mass here. I'm sure you have the feeling why. Okay, that's the game. Now, let's go to the results. The results are again on the left. The action 4, which is choosing the center, is once again the shortest response time. always the choosing something in the middle is the instinctive, it's the shortest response time action. The other short below the median is 53 seconds. The other below the median actions are the edges, 1 and 7, which of course are very bad choices. Actually, they're even from game theoretical point of view, they're dominated actions. So those actions, 1, 7, and 4, I declare as being the fast. The other actions, 2, 3, 5, and 6, I declare the relatively slow. And I will interpret them as being an outcome of being more contemplative. Questions? Okay. Again, by the way, what I promised you is again you will see this picture. You see these are the 2, 3, 5, 6, and this I put them together, but even if we would separate them, you will have the same story. These are by far to the right than the actions that I classify, the other 3 actions that I classify as fast. This is a game that I played with many years ago with my friend Guru Uberman. The story here is the following. Imagine you are participating in a game with over 200 participants worldwide. Each participant chooses to compete in one of 2 contests. In contest A is the coin, what I will call the coin contest. You have to guess the outcome of 20 flips of a coin. In contest B, you have to guess the outcome of 20 tosses of a die. In each contest, there will be one winner, and the winner will be the one who will be closest. His answer will be closest to the outcome or the random outcome that realization of the device. Is it clear? What is instinctive here to do? The instinctive here is to choose the coin. Why? Because it seems that there are fewer cases, only 2 to the power 20, small number, versus 6 to the power 20. So people, the instinct is to go on the coin. What is more thoughtful is actually to choose the die, because you say to yourself, aha, many people actually will choose the coin. And actually what is important here is not the absolute, but relative, unless you believe that you have some magical ability to predict the outcome, the random outcome, then you understand actually that you have to go into the contest with less participants, and that's more likely to be the die, and therefore the more thoughtful action here is die. Look at the results. The results indeed are in this line, namely again a huge difference between the die population and the coin. Here there is only 2,000 subjects, 71 seconds for the coin, 88 for the die. By saying only 2,000, I was cynical, just to make clear. Now here is again the picture, the red, the die is by far to the left of the coin. Hereby I declare that the fast here is coin and the slow is die. Now I will not bore you with all the 10 games. Let me move to 2 more games. This one which all of you are familiar with, which is the Ultimatum game. Again, it's without real money. Just imagine that you play the Ultimatum game with about $100, and you are the offerer. You have to say, you have to declare how much do you offer to the other side. This was the framing of the problem, was how much do you offer to the other player. Here you have the exact text, but it's not very important. I'm sure you understand the situation. And here I have actually a huge sample. It's more than 14,000. Now I have actually more than 15,000 subjects. And what is the median response time here is 46 seconds. Below the median is only the action 50. the action 50, which is very, very instinctive. First of all, I think about the fair division. I offer you 50, I take 50. This is the first thing that people think about. The other actions are above the median, and I will declare them, all the other actions I will declare as slow. Notice, we don't have time to talk about it, to expand about it here. Notice two things. First of all, we have some subject to offer to the other side more than 50. The question why? The reasons, I think I have some reasons to believe that there are two reasons, there are two causes for that. One of them is a mistake. People actually think about themselves and we think about ourselves too much probably. And therefore, even when I ask you how much do you think you give to the other player, actually you answer how much do you expect to get yourself. That's one reason, but it's not the only reason. I think that there is clearly a very large group of people that actually offer to the other side more than 50, either because of courtesy or because they want to make sure that the other side will accept. These are the people who are more strategic. They offer less than 50. They understand their bargaining position. Therefore, they offer to the other side less than 50.